This section's about isosceles and equilateral triangles. So isosceles means that two sides are equal, and equilateral means that all three sides are equal or congruent. So legs are the sides of the triangle that are congruent. So an isosceles triangle has two legs that are congruent. So the legs are here, here for the second one, and here. Those are called the legs. The base is the side that contains the two legs. So the base is right here for all three of them. The vertex angles are where the two legs come together. So right here, here, and right here, that's a 90. Those are the vertex angles. And the base angles are at where the base is on the side. So the base angles are right here, and right here. So in an isosceles triangle, I'll draw another isosceles triangle. You have the legs, which are congruent. The base is right here. The vertex angle is right here. And the base angles are congruent. The isosceles triangles theorem is if two sides of a triangle are congruent. So if two sides are congruent, then the angles are congruent. Then the base angles are congruent. The converse is if the base angles are congruent, I'm not going to write it out, but if the base angles are congruent, then the two sides are congruent. And theorem 4.5 doesn't have a name, but so if I have an isosceles triangle, here's theorem 4.5. This is the vertex angle. These are the legs. Theorem 4.5 says the bisector of the vertex angle, so this is the bisector of the vertex angle, is perpendicular and bisects the base. So if you know that these two angles are congruent, then you can make a 90-degree symbol right here and write these two sides are congruent. Okay, so we're going to use that right here. So because this shows that this is isosceles, right here this is an isosceles triangle, and that these two angles are congruent, this is the vertex angle, so this has to make a 90, and these two have to be equal right here. So now I can go ahead and fill in over here has to be 63 degrees because these two are base angles and they are congruent. So I have a right triangle. This is 90, this is 63, this is x. So I do 100 minus 90 minus 63. So this angle needs to be 27 degrees. And then over here, this is an isosceles triangle, so these two angles are congruent. So this angle right here needs to add up to 180. So this has to be 55 degrees, which makes this 55 degrees. So total, this is 110. And I need to have 180 degrees in this triangle, so I do 180 minus 55 gives me 70. So this needs to be 70 degrees. And in this figure right here, these are equilateral triangles. So all of the sides and all the angles are equal, so this has to be 60 degrees. And then number 2, explain why angle or triangle ABC is isosceles. So this angle is congruent to this one because these two lines are parallel. These blue angles are alternate interior angles. So if these two angles are congruent, that means their sides are congruent and it's isosceles. Okay, letter A. If the measure of angle BAC is 38 degrees, BAC, I'm going to draw this over here. So if BAC is 38 degrees, because this is BAC. We know it's isosceles. Find the measure of angle C. So these two have to be the same. So I'll let this be x. So it means that x plus 38 has to equal 180 degrees. So I have 2x plus 38 equals 180 degrees. So 2x equals, subtract 38 from both sides, 142, so x equals 71 degrees. So this one's 71 degrees. Letter B, if the measure of angle BAM, so BAM right here, is equal to the CAM right there is 23. So this is a perpendicular bisector down there. Oops, I didn't mean to put that symbol, these two. Then find BMA. Well, I already drew in that was a 90, so it has to be 90 degrees. Because remember, if this is the vertex angle and it's bisected, then this becomes the perpendicular bisector. It's perpendicular and it bisects this segment BC. And then the letter C is, if the measure of angle B is 3x, and the measure of angle BAC, which is the top vertex angle, is 2x minus 20, find x. So I know these two angles have to be congruent because they're the base angles of an isosceles triangle. So this one has to be 3x. So I'm going to set up that 3x plus 2x minus 20 equals 180. So 6x plus 2x is 8x's equals, add 20 to both sides, 200. Divide both sides by 8. X equals 25. Okay, then down at the bottom, I'm going to try to make this bigger here. Okay, so find the value of x and y. So this is this triangle right here. Because these two angles are congruent, this has to be isosceles. Same thing with the one over here. Okay, so then if the middle triangle is isosceles right here, then that means that this base has to be x as well. So if this one is 60, it's going to be x plus 60 equals 180. Well, when you solve for x, you're going to get 60, so this is 60 degrees. So these three triangles are all equilateral 60 degrees. So if all the way across is 18, then this has to be 9, this segment has to be 9, and then y has to be 9. So x is 60 and y is 9. Okay, and this last one we kind of already practiced a few times already, so in the last chapter. So ABCD EF is a regular hexagon, so all sides are congruent and all angles are congruent. And we're trying to find the measure of angle BAC. So I know that angle B, the measure of angle B has to be, the total is 620 degrees, and I have to divide it by 6. So we've done that a lot before. This is already 120 degrees. So then you have this triangle that is 120 degrees right here, and then this triangle is isosceles. So that means that these two angles are congruent. So I'm going to do x plus 120 equals 180. 2x plus 120 equals 180. 2x equals 60. So x equals 30 degrees.